So let's pick up where we last left off. We were looking at a system of simultaneous equations, and we had discussed that they both have to have the same pair of variables in both equations. Now our system has two unknowns, and hence we need two equations to be able to solve for them at the same time, because simultaneous equations means that they occur at the same time. So let's begin with our elimination method, and the elimination method can be used in a case where your variables have the same coefficient, and usually I find that the easier way to do my elimination. When I want to eliminate a pair of a variable from a pair of equations, I'm always going to look at the variable's coefficients to determine whether or not I can use my elimination process a little more easily. Now, it's not to say that it can't be applied in a case where the variables have different coefficients. So what we're going to do in today's video, and in this particular session, we're going to look at the elimination method applied to this system of equations in both cases. So we're going to start with the easier of the two ways of applying elimination method. So let's get started. The first thing I want to do is identify a variable to eliminate. Now, as I was saying before, elimination method can be easily applied whenever you have a pair of variables that one of the variables have the same coefficient, right? So if I look carefully at my two equations, if I look at the variable y, one of the things that stands out to me is that they both have a coefficient of 1, despite the coefficients having different signs, which we'll get to a little later. But let's work with eliminating the variable y. If I choose to eliminate the variable y from these equations, the next thing I need to do is be able to identify what operation can be performed, so I'll get rid of them from the equations. Now, because I'm trying to eliminate y, I have to pay attention to these signs. So this is where the signs come in. And since my signs are both different, what I'm going to do is perform addition on this pair of equations, and I'll be able to eliminate the variable y. So let's perform this operation of addition. So we're currently at step 3. where we're choosing the operation which helps us eliminate the variables that we want to eliminate. So from here, what I'll do, I'll perform the addition on each term in both equations. So this is what you're treating it as. Just like back in primary school when you were adding all those large whole numbers and you would have place values, you're treating it like a huge sum, and we're going to start from this way. So we're starting from the first terms in our equation. So 3x plus 2x is going to give me a sum of 5x. Now I'll move on to my next variable, and I have minus y and plus y. So if I add these two together, I'm going to remain with 0. So I don't need to include y in this result. So I'll move straight on into my constants. My constants here are positive 10 and positive 5, and when I add these together, I'm going to get a sum of 15. Now the purpose of doing this is so that we get rid of one of those variables. So now this looks like something that we can solve, because this is a one-step linear equation with one unknown, which makes it really easy for us to just get that value. So let's solve this equation. Now when we solve this equation, we are going to simply divide both sides of our equation by the coefficient of x. So the coefficient of x here being positive 5, let's divide both sides by positive 5. And dividing both sides by positive 5 will now leave me with my answer for x. So the value for x is 3. Once I have my solution for one of my unknowns, I'm going to move straight into finding my other unknown, because I had two unknowns, so now I must find for the other. Let's substitute this value into one of our equations. So now that we have the answer for one of our unknowns, we're going to take one of the given equations and we're going to substitute our answer into one of them. So you can choose either one. I'm going to go with equation 1 in this case. So substitute our answer for x, which is x is equal to 3, into, as I mentioned, I'm going to work with equation 1. You can use equation 2 if you like. So if you're following along, you just follow along and you can substitute into equation 2, but pay attention to how you make the unknown the subject. Alright? Okay, let's do a substitution. From here now, I replace x with the value that I got for x. So notice, in the first equation, my coefficient of x is 3. I open a bracket and I'm going to replace x with the value that I got for x, which is 3. So 3 times 3 minus y is equal to 10. I'm going to simplify, and then I'll rearrange this equation to solve for y. So 3 times 3 is 9. So I remain with 9 minus y is equal to 10. And then from here, to solve for y, what I'm going to do, I'll add y to both sides because I can't solve for a negative y, right? It's not to say that we can't do it the other way as well, but I'm doing the way that I think is fastest for me. You can work to suit your own preference. So I'll add y to both sides. And what that does is eliminate the y from on the left hand side. So I'll remain with 9 on the left hand side is equal to 10 plus y. And then from here, what I'll do is subtract 10 from both sides. So when I subtract 10 from both sides, I will now remain with my value for y. So this will give me that y is equal to negative 1. Alright, so my solutions, I'll write that to the side here. My solutions are as follows. I've gotten that x is positive 3 and y is equal to negative 1. Now, the last step, and it's an unofficial step because it's not necessary, but if you feel like you lack that confidence and you want to check to see if you're correct and you're confident that you can do substitution and simplifications, you take your answer and plug it into one of your equations. Now, since I substituted x equal to 3 into equation 1 and got negative 1 for y, I'm actually going to substitute both these values into equation 2 now to see if I get the same solutions working in this equation. So essentially, if I plug in these values into 2x plus y, they should equate to 5. And if they don't, well, I did something wrong. So let's see, am I correct? So my validation would look something like this. I'm going to replace x with 3 and y with negative 1. And let's simplify, shall we? 2 times 3 is 6. And 6 plus negative 1 gives me 5. So I can see right here that my solution is correct because it satisfies both my equations. And remember, like I said, this validation step is only if you want to verify that your answer is correct, and only if you feel like you're not too sure if your answer is correct from your solution, right? So this is how you use your elimination method, and particularly when the coefficients have the same numerical value. Notice it was pretty simple. Alright, it was pretty simple, although it seems like a very big set of steps. It's just really and truly outlined in this way because I think it will help you understand what you're doing at each bit of this solution. Now, like I mentioned in the beginning, you can use elimination as well to eliminate variables where the coefficients are different. So why don't we take a look at how we do that elimination process with this same system of equations where we're going to look specifically at the elimination of the variables x. So I'm going to write back my system of equations first. So my equations were 3x minus y is equal to 10. And I'll label my equations as well. So equation 1. And my second equation was 2x plus y is equal to 5. Equation 2. So my elimination process begins with me being able to identify a variable to eliminate, and as I said, I'm going to try doing the elimination process to get rid of x instead. Now if I look at both of my coefficients, I notice that they both have different numerical values. And what I do in a case like this is I'm going to need the LCM of these coefficients, where I'll bring both my coefficients to one of the common multiples of those two numbers. So my LCM is going to be critical here, so I need to know how to find LCM. Now, if I can recall my LCM quite easily, my LCM for 3 and 2 is 6. To bring both of these equations so that the terms in x both have coefficients of 6, I'm going to take a factor and multiply each of these equations by it so that I can get the equation to have a term in x with a coefficient of 6. But in doing this, I need to multiply the entire equation. So let's start off first of all. We know that the LCM of 3 and 2 is 6, right? And in my first equation, I have a coefficient of 3. So what would I multiply 3 by so that I would get 6? In this case, I would multiply by 2. So I'm going to multiply all of equation 1 by 2. And then I have to do the same procedure on the second equation, but I'm going to ask myself, well, what would I multiply 2 by so that I would get 6? And in this case, it would be 3. So in doing this process, I'm going to create 2 new equations. And these 2 new equations are going to be as a result of multiplying them by this factor. So let's multiply both equations, and then we're going to work on the elimination process. So what makes the elimination process a little lengthier at times is the case where you have to bring both of the equations so that they have a term where the variable that you want to eliminate, the coefficients are the same. So equation 1 by 2 would give me 6x minus 2y is equal to 20. And because I've created a new equation, I'm going to label this equation 3. And then my second equation multiplied by 3 would give me 6x plus 3y, and 5 3s are 15. So these are our 2 new equations. We're going to use these to do the elimination. We don't use the given equations any longer because those will not help us in our elimination process. Now, I'm going to look at the variables, the terms in x, and now let's look at the coefficients. So my coefficients are both 6, and in a case like this, both the coefficients are positive. So since they have the same sign, this means that we can do our elimination process by doing subtraction. So let's subtract both these equations and let's see what we get. So equation 3 take away equation 4, 6x take away 6x is leaving me with 0x, so I don't even need to write that in. Now let's move on to our terms in y, and this is where the integers come in, so do be careful. Minus 2y take away 3y. I'm going to remain with negative 5y. And then 20 minus 15 is going to leave me with 5. Right? Okay, let's continue. So I just flashed back for a second there because I'm solving for y, so I wanted to remind myself what was the value I'm working towards, right? So now obviously you wouldn't have that, but it's just to make sure that we're on the right track. So here I have to solve for y, and I have to divide both sides of my equation by the coefficient of y, which in this case is negative 5. So let's divide both sides of our equation by negative 5. And this is going to give me my solution for y. So I'm going to get that y is equal to negative 1, right? And like I said, I just flashed back for a quick second to just double check. Last time we did the elimination in the system, we got y to be negative 1. One of the things that we need to be sure of now is which equation we're going to use. We can use any of the equations, either one that we were given or one that we created. So whichever you feel more comfortable working with, you choose that equation, and I'm going to work with equation 1 in this case. So let's substitute. Y is equal to negative 1 into equation 1. What this is going to do is help us solve for our next unknown. So in equation 1, I'm going to replace y with negative 1. So let's simplify, and we will get that 3x plus 1 is equal to 10. Subtract 1 from both sides, we're going to get 3x is equal to 10 take away 1, which will leave us with 9 on the right hand side. And then the last thing to solve for x is divide both sides by 3, which in this case is going to leave us with x is equal to positive 3. So we have our solution, and again we can do a validation, right? So let's just say we want to validate our answer. We can take our solution, substitute it into any of the equations. So let's try one that we would have created, right? Doesn't necessarily have to be one of those, but let's try one of those. So let's work with equation 4. So what I should get when I substitute the values of x and y, I should get that this is going to equate to 15. So 6 times 3 plus 3 times negative 1. So this will give me 18 plus negative 3, which is positive 15. So we see that it works out, so we know that our solutions are correct. So we get that x is equal to positive 3 and y is equal to negative 1. And these are the answers we would have gotten when we did it with the elimination method the first time around. So you have a choice. You can eliminate x or y. I've done both ways with the elimination to show you what it entails. And like I would always say, whenever there are multiple ways in which you can get a solution, you're more than welcome to use the one that you feel most comfortable working with.